Welcome to IT Pro TV. I'm your host, Don.
Coming at you live from San Francisco, California.
You're watching IT Pro TV.
Hello, and thank you for watching IT Pro TV, helping you level up with IT learning everywhere you go. I'm your host, Zach Memis, for this episode of CompTIA Linux Plus. Managing file permissions is what we're talking about, and Don Pizzetta is here to tell us all about it. Don, good to see you.
Hey, glad to be back. And in this episode, we are going to be looking at file permissions. In a previous episode, we saw creating user accounts and groups, which are all great. But once you've got them, you've got to make use of them. One of the best ways to do that is to assign permissions to files. Then you can control exactly who has access. And there's a few different ways we can do that inside of Linux. And so that's what we're going to take a look at right here in this episode is how do we view the permissions that are there? How do we edit and change them? How do we assign them? And how do we make the best use out of that permission structure inside of the Linux file system? So that's all coming up right here in this episode.
So, Don, how do we see what file permissions are set on a file?
Well, if you were a sharp viewer, you might have noticed we've kind of already seen them. That ls command where I was pulling up listings. Well, normally it doesn't show permissions, but if you do ls-l, right, get the longer listing where it's actually in a true list format, you'll see the permissions on the screen, but you might not recognize that's what they are because they're written in a really strange way. Let me show you what I mean. So I'm going to go to my CentOS box here, and let me just go into a terminal. And I'm using CentOS, but everything you see in this episode works on CentOS and Ubuntu, or if it's Debian-based or Red Hat-based, it's the same across the board. This is a really fundamental concept inside of the Linux operating system. So if I do a ls and just pull up my directory, right, I see some various files, and there they are. But if I do an ls-l and get that longer listing, I see the file names, and I see a lot more, right? There's a lot of different things that are nested away inside of here. But the first couple of columns that appear actually have to deal with permissions. That's what we're seeing right across here, are the permissions themselves. And then we see things like the date the file was modified or created, the time that it was modified or created, and the name of the file. So that kind of more normally stuff, right? But the left side may just look like a whole bunch of mess at a first glance, right? But what you're seeing are the permissions as they're assigned to the users. Now, I've got an illustration that kind of shows this and breaks down what we're looking at. Each of the letters that are represented in that information, it communicates something, right? The very first letter tells us whether or not we're looking at a directory or a file. So if you see a D, that's a directory. If you see a dash, in other words, it's empty, that means it's a file. And going back to my listing, you can see that. I've got a folder called downloads right here, and that's a directory. So the very first letter is D. And right after that, I've got file1 through file5.txt. They're files, and so the very first letter is nothing. It's empty. They're blank for a file. So that's the first indicator. And that's important because directories are handled differently than files. Obviously, we need to be able to navigate inside of them. Then we follow that up with 3 sets of 3 letters. So basically 9 letters in a row. But they're broken into 3 sets, and each one is identifying a particular set of permissions. The first set is indicating the permissions that the owner of that item has. So if you are the one who created that document, or if you created that folder, you're the owner, right? I mean, assuming nobody's come and changed it later on. But if you created it by default, you're the owner. And as an owner, you normally have a lot of permissions. And those are being shown right here with this RWX. RWX is short for read, write, and execute. Okay, read means that you can open that file and look at what's inside of it. Write means you can change what's in that file and modify it, even delete it if you want. And then execute means if it's a program, you can run it. If it's a document, it doesn't do anything, right? But if it's a program, you need to run it. Now, directories need execute permission on them because navigating into a directory is effectively executing that directory. So directories are treated like programs in that respect. It's a little bit weird. But there's that RWX. That's identifying permissions for the owner, whoever made it, okay? Then we have another set of RWX, and these are the permissions assigned to the group. There's a group that's attached to this particular document, and they have a certain set of permissions as well, and it'll show RWX. Now, notice on the diagram here, we've got R-X. That means they have read and they have execute, but they do not have write permissions. So they could open the document and look at it. If it was a program, they could run it. But if they tried to change it, they would get permission denied. It would not allow them to modify it or delete it for that matter. They wouldn't have that permission. And then the last part here is what's called other, right? And the other, this is anybody who's not the anybody who's not the owner and is not in the group assigned to the file. So let's go back to my directory here. Notice I've got file 1, 2, 3, 4, and 5. Okay. On all of them, I'm the owner. So DPZ is listed as the owner for each one. And on the left side, I can see as the owner, I have read and write permissions. I'm allowed to modify all 5 of those files. Okay. But the group changes on each one. I've got marketing as the group for a few of them, and sales as the group for one of them, and me as the group for 2 other ones, right? Well, let's say that I'm in the sales department. When I come and access file 3, it's going to look at which permissions to apply to me, right? Well, for me, I'm the owner, so it'll see, hey, DPZ is the owner. Those are the permissions that it'll apply, and I would get read and write. But let's say Zach is in the marketing team. When Zach comes along and accesses, let's see, he accesses file 1. He's not the owner, so that gets skipped. And he is in the group. He's in the marketing group. So the second set of permissions would apply. And, whoops, let me highlight the right spot here. And so he would end up with read and write because he's in marketing. But let's say that Zach accessed file number 3. File number 3, well, he's not DPZ, so he's not the owner. And then he's not in the sales group. He's in the marketing group, right? So he's not in the sales group. So that one doesn't apply. So in that scenario, it skips the first 2 blocks and it goes to that third block, to the other block. And this is basically anybody else, anybody who's not the owner, anybody who's not in the primary group. Then after that, everybody else gets this applied. And you can see right here that he would just have read access. He could open the file, but he couldn't change it or delete it or whatever. And a lot of times we might even take that away. And you'll see where the other group just has 3 dashes. In other words, they don't have access. Only the owner and only the group would have that permission. So that's the way these permissions are kind of being written out. And going a little bit further, what you'll see is, you've got the permissions listed here, and we know the format of that block, right? That we have owner followed by group followed by other. Well, other is, anybody who doesn't match, right? But owner and group need to be specific entities, and those are always listed to the right. And so I can see the owner followed by the group right there. And so with those 2 pieces of information, we can put that together and figure out exactly what somebody's going to end up with. In the diagram here, we actually don't see who the owner and the group are. So this doesn't actually, this wouldn't be enough information for me to figure out, does Zach have access to directory A? I don't know. What group is it? What owner is it? Zach might be the owner, in which case, yeah, absolutely he's going to have access to directory A. But even without knowing the owner and the group, I do know that Zach would get read access because the other permissions are set to read. Right? Now, when we look at this stuff in our permissions, I do want you guys to be aware of a couple of different notations that you might see out there. And let me just bring this up. A lot of times these things will get abbreviated. So I keep mentioning the user, the group, and the others. Those are usually going to be abbreviated down to U, G, and O. That'll be important because we're going to see that in a few other places. So U, G, and O. I talk about the owner of a file, and it's easy to get that confused in our head and think owner is O. But it's actually the user who owns the file, and so that becomes U. O is attached to others. So make sure you differentiate that in your mind, especially on the exam. You don't want to mix those up. But U is the user who owns the document. And then the permissions we already saw, right? Those are just R, W, and X, read, write, and execute. Or if there's no permissions, it'll be just a hyphen or a dash in there saying that they don't have permissions. So those are the abbreviations that you're going to see in most of the commands that we use.
Don, were permissions set with numbers in the past?
They were and they are technically still. So the letters that I'm showing you here, they're kind of nice because they make things easy. If I tell you R, that's read, or W, that's write, RWX, you get read, write, and execute. So those are very human-friendly ways to set permissions. But in the olden days, which really wasn't that long ago, maybe 10 years ago even, we didn't have those letters. Instead, we had a numerical system for representing the permissions. And that numerical system was kind of a pain. Let me show you here. Let me go back to my little tables. Here we go. The permissions read, write, and execute were written in a numerical form. It was based on some binary values, so that's why it's 1, 2, and 4. 1 was execute, 2 was write, and 4 was read. Those were the three numbers that indicated permissions. But where it got tricky was if I wanted to give somebody, let's say I wanted to give Zach read and write permissions. Well, what I would actually have to assign to him is a permission value of 6. 6 is 4 plus 2, right? That's the read value plus the write value. That gets us 6. Or if I wanted to give him read and execute, well, that would be 4 plus 1. That would be 5. 5 would give him read and execute. Or if I wanted to give him the whole thing, read, write, and execute, I would add all three together and get 7. So when you actually went to assign these numerical values, things start to look a little bit weird. Let me bring up a slightly bigger table here. This is the same basic information, but now I'm combining permissions, right? Just execute is 1, just write is 2, just read is 4. But if I want write and execute, that would be 3. And that's a really rare permission to assign. You wouldn't normally give somebody write and execute. Read and execute, that's a 5. That's actually pretty common. Read and write is 6. Read, write, and execute is 7. And we would still be assigning those based on a user, a group, and an other, the U, G, and O. You would have a different number for each one. So if I wanted the user to have read, write, and execute, and I wanted the group to have read and execute, and I wanted the other to have none, then I would set the permissions to 750. 750. The 7 would apply to the user, the 5 would apply to the group, and the 0 would apply to the others, everybody else. So it looks like I'm setting the permissions to 750, but it's actually the 3 separate blocks again, right? User, group, and other, and those are being assigned out. Now, those numerical formats still work today because in the background, that's what's happening. But the letter formats, what I was showing you up here, these guys, that's what's designed to make life easier on us as human beings. And you can do everything with these letter notations that you can do with numbers. So there's really no reason to use the numbers anymore, but it certainly doesn't hurt to learn about them and know that they exist, because as you go and look at scripts or walk through tutorials online, you'll find a lot of documentation is pretty outdated, but still valid. And they'll include doing things like setting with the numbers. It's a really common thing to see. But all the major distros today support the letter notation. And on the exam, you're typically going to see the letter notation, although the numerical notation is testable material. So we do still want to learn that, even though it might not be our primary form. So that's that numerical notation. You certainly may see it out there, but it is the older way of doing things.
So Don, how do we modify the permissions?
All right, so far we've just been kind of looking at them, right? If we want to get in and change the permissions, there's actually several different commands that can do it. In a way, we've kind of already done it a little bit. Remember when we created some groups in another episode, and we showed switching our group context, and that's how I ended up with these files that had different groups attached to them. But I never really set the permissions, and that's why if we look at the permissions, they're mostly the same. I say mostly because I do have a couple where the group only has read access versus read and write. Things have gotten mixed up a little bit, right? So maybe I want to get in and fix that. I want to change it. I want the user in the group to have read and write access, and I want the other people to not have any access at all, okay? So I can get in and modify those permissions and change it, get it kind of cleaned up. And the command that we're going to use for that is chmod, okay? If you do a man chmod, that'll pull it up. And basically what it stands for is to change file mode bits. And those file mode bits, those are the numbers that indicate the permissions that you have. But we don't have to know the numbers because we can use the letters. And the documentation goes on to list those. You'll see that UGO right there. And then we'll see the RWX all laid out next. And there's a couple of special permissions that we don't need to worry about just yet. But each of those are kind of laid out in how that command works. But let's set that document aside because it's really big. And let's focus in on some of these. I'm going to take file, let's take file 3. Okay, I want to fix file 3. I want the user to be able to read and write. Well, that's already correct. I want the group to have read and write. So I need to add write permissions. And I want the other to have nothing, have no permission. So I want to remove the read permissions from other. So I can use chmod to do that. Basically what you do is you type chmod, and then you specify the letter of the identity you want to change. All right. For me, the user is fine. I want to change the group. So I'm going to say G, and then I can either add or remove permissions. I want to add the right permission. So I'm going to say plus W. So G plus W, I'm adding that permission. And then I need to specify the file that I'm going to modify. I'm modifying file3.txt. And when I run that, I don't really get any great feedback, but up here I can see file3.txt was read only for the group. And now if I do an ls-l, and I'll just pull up file3, or here, we'll do file star. There. Now I can look at it, and file3 has read and write for the group. So I've added the right permissions. And taking away permissions is the same thing. So I could do chmod. I want to remove permissions from the other. So I'm going to say O minus R file3.txt. And so that's going to take away those permissions. Okay. So by doing that, we can kind of get in there and make the appropriate changes that we want and get it done pretty easily. In fact, I could have saved a little bit of time. Here, let me pull up that listing again. Let's take here, file number 2 is also messed up. So file 2, I want to add write for the group, and I want to remove read from other. Well, I could actually do both at the same time. I can say chmod, I'm going to do group plus W or G plus W, and then just do a comma, and I can say O minus R file2.txt. You separate with a comma, and you can change the permissions however you want. In fact, I can even go back and maybe I want to add for the user, I want to add execute. Maybe this is a script, and so I want to add that in there. So U plus X, G plus W. I can even add more than one permission at the same time. So maybe I want to add RW, whoops, I have to type it in the right order here, RWX, there we go. So I'm taking the group and I'm adding read, write, and execute all at the same time. So G plus RWX or O minus, maybe I didn't look ahead of time, and I'm saying I don't know what permissions the other has, so I'm just going to say minus RWX. I'm going to remove all three. It doesn't hurt to remove something that's not assigned. It's just going to try and remove it again. And so when I run that, it's going to apply all those changes at once in a single command. And if I pull up my listing and look at file 2, notice how file 2 is turned green. And that's because it's executable now. So it thinks it's a program, even though it isn't. But I can also see that the others have lost their permissions. They have no permissions assigned anymore. We took that away, simultaneously granting permissions somewhere else. Right? And there's one more way we can do it. I use the plus and the minus. Plus is great for adding. Minus is great for taking away. It leaves permissions alone that are already assigned, though. Okay. So, for example, if I wanted to take away or add one permission, it doesn't mess with the other permissions that are set. Maybe I want to override that. I want to guarantee that things are configured exactly a certain way. In that scenario, you can use an equal sign, and an equal sign will overwrite whatever the permissions are that are there already. So for example, I could say chmod U equals RW, and then G equals RW, and O, and I'll just do minus RWX on that one. So I'm just going to take away whatever's there to remove that. And then I'll do all of that on file2.txt. All right. Now, because I use the equal signs, what I'm saying is I want the user to just have read and write, and it's going to take away execute. Okay. Because I used equal, and we can verify that worked. And when I look at it, sure enough, file2 now just has read and write for the user in the group. So plus and minus is modifying. Equal is overwriting. We can actually just change it outright and put that in place. So that's how we can do this using the letters, and that's honestly the easiest way. I could achieve the same thing with the numerical system, right? So if I wanted to take, let's say I wanted to take one of these other files here, like file 4, or file 4 and 5, whatever, and I want to leave it where the user in the group have read and write permissions, and I want to make it where the other has nothing, okay? Well, I have to remember with the numbers, okay, read and write. I can go back to my table here. If I want read and write, that's a 6, right? So it's going to be 6 for the user, 6 for the group, and then 0 for the other because I want to take away permissions. So what I would do is I would say chmod 660 file4.txt and run that, and then do the same thing for file 5. Could have used a wildcard there and save some time, but we'll do it that way. And now when I look, I can see those permissions have been taken away from the other, but we had to use the number format. The number format might be a little bit shorter, but it's harder to remember those numbers, and that's where the letters really come in handy.
Where do the default permissions come from, Don?
Good question, because all these files already had permissions,
Mhm.
and I didn't specifically set them, so those permissions are coming from somewhere. If I create a new one, I'll create file 6. So if I just do touch file 6.txt, all right, and I take a look at, here, just list it that way. If I look at it, it set me as the owner and me as the group. Now that makes sense to me because I made the file, so I kind of get that, right? But the permissions, it set the user to have read and write, it set the group to have read and write, and it set other to have read only. Where did that come from? Well, in Linux, you have something that's called a UMask, and the UMask is what defines the default permissions. Now, it might seem like an easy thing, but it's actually a little bit complex because there's more than one level that's involved here. There's permissions that are set at the system level, where a user's not really involved. It's the operating system that's creating files, like temporary files and things like that. But then there's files that are created by us, the end users. And there's usually a different set of permissions that are required on those. The system needs one type of security that's usually much stronger versus users where it's a little bit weaker. And so the UMask is what defines a lot of this stuff. If we want to take a look at that UMask value, we can find it inside of our profile or inside of /etc. It's a few different places. Inside of your profile, so I'm going to just do cd till to make sure I'm in my home directory. So if I do a pwd, I can see I'm in /home/dpossett. And if you do a ls-la, you'll see there's a number of hidden files inside of your home directory. And one of them is .bashrc. That's your bash configuration file. Bash is the shell that we're in. And if I take a look at that file, so I'm going to type less dot slash, or I can do tilde slash dot bash rc, and take a look inside of it. Now I can see the contents of that file. And as you look through, you may or may not see a UMask line in here. And it'll say UMask equals followed by 3 numbers. Now, I don't see one in mine. So that means, well, it could mean a few things. It may mean that I don't have one set, in which case I'm just using the default one from the system. But it can be overridden here, and a lot of distros do that. Like I believe Ubuntu actually overrides by default, and so you would see a UMask entry in here. Another place that it might end up is in your profile, which you may have noticed another hidden file, which was that bash profile. Let's just take a look at it real quick and see if it's tucked away in there. And nope, not there. Okay, so I don't have UMask overridden from my user, so I'm just using whatever the default on the system is. If we want to see that, that one is tucked away inside of /etc/profile, all right? And when I take a look here, I'm going to see other settings that apply globally to users. This is the default profile. And as I look through here, and it might be faster for me to do a search, we should, oh, there it is. We can find the UMask there. All right, so right here, we can see by default, we want UMask to get set. This sets it for the login shell. Current threshold for your system is set to 200. You could check UID, GID, reservation validity, blah, blah, blah. So this is talking about our user ID numbers. But after that, I actually see the UMask numbers that are being set. All right, those numbers define the default permissions. Now, we just talked about how these file numbers match up to permissions, and I'm seeing 002 and 022. Okay, well, if I go back here to my table, 002 would mean the user gets nothing, the owner gets nothing, and everybody else gets right. That's a really weird permission to assign. That's because UMask actually follows its own numerical structure because, we can't have everything be the same. That would be crazy. So it's actually kind of backwards from the way that our normal assignments are. With normal permissions, a 7 would be read, write, and execute, and a 0 would be no access. But in UMask, it's flipped around. It's flipped around so that 0 gives you everything and 7 gives you no permissions. So when I see a 002, that means the user gets everything, read, write, and execute. The group gets read, write, and execute. And then everybody else is getting read and execute. Now, I know from looking at my files, that sounds close to what I got, but these are all saying execute. And we didn't see that. In the file that I made, let me go and pull that back up. In the file that I made, it was read, write, and read. Nobody got execute. Okay. The reason it shows execute on the UMask is for a directory. If I were to make a directory, so let me just do mkdir. I'm going to make a directory. I'll call it test underscore files. All right. So I'm creating a directory called test files. And if I take a look at the permissions on that directory, look what I see there. Read, write, and execute for the user, read, write, and execute for the group, read and execute for everybody else. All right. A directory needs the execute bit set to be able to navigate inside of it. You're executing the directory to view what's inside of it. And that matches up exactly with the UMask that we're seeing on the system. And then on the files, it defaults to not setting the execute bit. So a little bit of a variation there. But that UMask defines where those default permissions come in. And maybe on your system, you're really worried about security. And so you want to tighten things up a bit and you want to remove that other permission. You could go and change the UMask. And then now every file you create after that point would adhere to that new model. Or you could override it just for your user. Go into that bash RC file and add a UMask equals entry in there, and that'll override it, and now you'll have an all new set of default permissions. So that's all kind of tucked away right there under UMask.
So Don, how do we change who the owner of the group is?
Yeah, so every example that I've done so far, the owner in the group has already been assigned.
Yeah.
Now, it's assigned based on who creates it. So if you're the user that creates it, you're now the owner, and whatever your primary group is gets assigned to be the group. I showed in the groups episode how we could use the new GRP command or new group to switch to one of your other group contexts. And then when you create a file, it'll be created with that new context. So if you remember to do that, great. I can tell you that this guy right here forgets every single time. I always forget the new group command. I don't forget the command. I just forget to use it. And then I create all these files. Now the group is set wrong. So it's pretty common to have to go in and change the group. We actually have two different commands we can use. There's one specifically called chgrp or change group, and you can use that to change the group of a file. But I don't use it all that much, and the reason is there's another command, chown or OWN, which is short for change owner. And the change owner command can change both the owner and the group. So if I can knock it all out in one go, why bother using two different tools, right? So change group can be used, but change owner can actually knock them both out at the same time. So let me show you how I can do this. Let's say, for example, here in my home directory, I've got all these files, right? And I want them all to be owned by the marketing team. Okay, so the marketing team should be the group of all of these files. I'm the owner, dpossett, and now I just want that group to be changed. Well, let's say I want to change the owner as well, right? We created a user, JDoe, the other day. And so I want JDoe to be the owner, and I want marketing to be the group. I'm going to change both. Well, you can use chown and then specify who you want that owner to be. Maybe I want it to be JDoe. And if I was doing the chgrp or change group command, I would just specify the group name next, right? But with change owner, you can actually do a colon and then specify the group as well. And I want the group to be marketing. So I'm going to say JDoe marketing. And then you specify the file that you want to change. So maybe it's file1.txt. I'm going to use a wildcard and just get file star.txt. I want to get all of them. And I'll run that. And I get an error. Okay. Now, the command is typed correctly. But the error that I'm getting is that I can't change the ownership of the file. I'm trying to change it to John Doe. Well, if I do that, if I change it to John Doe, then I'm not the owner anymore. I'm not allowed to manage the file. If I'm in the marketing group, I'd be okay, but what if I'm not in the marketing group, right? I might be changing this to permissions that I don't have. So when you go to change ownership like this, you will oftentimes need to sudo the operation, run it as a super user to override that. That's a pretty common thing. If you were just changing the group from one group that you were in to another group that you were in and not changing the owner, a lot of times there you don't have to sudo it. But in my case, I've gotten in the habit of always doing it because of situations just like that. And so when I sudo it, there it goes. It runs with super user privileges. And when I take a look at those files now, I can see that John Doe is now the owner and marketing is now the group, and it did it across the board. Now, let's say I didn't want to change the owner. I just wanted to change the group. Well, again, you might say to yourself, I'll use change group for that. I could do chgrp, specify marketing as the group, and then file6.txt like that. All right. But I said I could use change owner to do this as well. With change owner, you can actually do something kind of interesting, which is if you leave the owner blank and just type :sales, for example. Since I'm leaving the owner blank, that tells it don't change the owner. Just leave the owner the way that it is. And we're going to change the group to sales. and I'll do file star.txt again. Actually, let me remember to sudo that since I'm not the owner of these files anymore. And so I can run it like that. By saying :sales, JDoe should still be the owner. And sure enough, JDoe is still the owner, but now the group is tied to sales. And I can go back and manipulate this over and over again. In fact, if you mess around with your stuff enough, you can end up in situations where you've accidentally locked yourself out of files. And so for me, there's several times where I might need to go in and totally seize ownership, not just of a file, but a directory and all the subdirectories underneath it. So let me show you an example of that. Let's say that I've really messed something up here in my home directory. And so I want to make sure that I own everything in my home directory. I should, right? So I want to make sure. So what you can do is you can use sudo, because you need to be a super user to override other people. And I'm going to say CHOWN. I'm going to change the ownership. And I'm going to set it so that dpossett is the user. And I'm not going to override the group. I'll leave it to whatever group happens to be set right now. Or I could do a :dpossett and reset it to my own group, right? And I want to do everything. So I'm just going to say star. And actually, let me do a ~star. I want to be very specific about the directory. This is going to be my home directory. I could even type it out just to be on the absolute safe side, because I certainly don't want to run this across the hard drive. If you take ownership of certain files, you can actually break the system. So you got to be really specific. If you add -R to this, okay, and on most Linux distros, you can use a capital R or a lowercase r, it doesn't matter, but on a few of them that are still sticking to the old BSD compliance, they require it to be a capital R. So I've gotten in the habit of always doing a capital R, even though it's usually optional. So that R, that -R is telling it to be recursive. Not just to look for files right here in this directory, but to look for files in every subdirectory as well. So I can crawl across an entire directory tree and reset ownership or change a group or whatever. chgrp, change group, it works the same way. chmod works the same way. If I'm changing permissions, group, or owner, use the -R and it'll get all the subdirectories as well. And so when I run this, it's going to start right in my home directory, hit every file, and then crawl across those subdirectories. The bigger the amount of data you have, the longer that command will take to run. So you might have to wait a moment for it to get through everything. But when it's done, I should be able to come in and look at my files, and I see that I'm now the owner again. And the group did get left alone. I didn't override the group, but now I can look at everything else inside of my directory, and I've kind of seized control of all that data again.
Managing file permissions, another awesome episode. And Don, do you have anything else you'd like to add?
Do be careful with messing around with permissions. You can accidentally expose data to people you don't want to have access to. So you want to be restrictive as possible on this. Also keep in mind, if you're doing backups, a lot of times in the Linux world, to back something up, we'll just take like a gzipped archive of it. When you take an archive, if you use the tar command to wrap up the files first, the tar command will actually back up the permissions as well. And that way, when you restore, when you untar the archive, the permissions will actually be preserved, even though it was backed up and restored. Otherwise, if you don't do that, when you restore, the permissions all get reset to default. So it's something to be aware of. We'll take a look at archivers in another episode in this series.
Great advice, and thanks for the little cliffhanger there. There's more to look forward to in CompTIA Linux Plus. Make sure you watch every single episode. You're going to be so glad you did. And take advantage of supplementary information that's in our course library. It'll help you be even more successful, so check that out too. And tell everybody you know about IT Pro TV. IT Pro TV is binge-worthy. Thanks for watching. I'm Zach Memis.
And I'm Don Possett.
We will see you again soon.
Thank you for watching IT Pro TV.